All right, calculator part. So when the graphing calculator is required, like I said, it only takes about half the problems. So look at this first one. Here's an example of where I know for sure I'm not going to need a calculator. And one of the dead giveaways to know you're going to need the calculator is that you're going to see decimals in the answers. So here we go. We got the graph of function f is shown above. So we got f is shown above. Which of the following statements about f is false? So this is f. So I'm going to make a note to myself. That's f. All right, f is continuous. Clearly not continuous. Got a hole. So that, which of the statements is false. So seems like that's going to be it. Okay, because it says which one of the statements is false. Well, we know it's not continuous because of a hole. Has a relative max at x equals a. Oh, I remember this one last year. We had a disagreement on this. Which of the following statements about f is false? F is continuous at x equals a. Clearly not continuous because of a hole. X equals a is in the domain of f. It is in the domain because there is even though there's a hole, there is a point though. So that one can't be that one because that's true. The limit as x approaches a from the right is equal to the limit as x approaches a from the left. Yes, the left and right do agree, so that is true. Okay, that is true. And the limit as x approaches a of f of a exists, that is also true because if the limit from the left and the limit from the right agree, that has to be true. Now, this is where we had disagreement because we felt like this was also false. But I think what they're saying is it can be true that this point could be a relative max. So you don't see that hardly ever, so I wouldn't worry about it too much. But what we came to the conclusion is we knew A was false last year. We were like, okay, A has to be false. So we know the answer is A. Did not require a calculator. Okay. Next one, obviously it's going to require a calculator, so I'd practice calculator stuff with me because I think the hardest thing on the AP exam is the calculator stuff. Let f be a function given by f of x equals 3e to the 2x. Let g be the function given by g of x is equal to 6x a third. At what values of x do the graph of f and g have parallel tangent lines? So if we want these tangent lines to be parallel, basically what I'm saying is their derivatives have to be what?
Equal?
Yeah, if we want parallel tangent lines, we want slope of the tangent lines that are exactly the same. Parallel lines have the same slope. So we want slope of the tangent. We want f prime of x to equal g prime of x. Okay, this would say we have parallel tangent lines. So I'm gonna do the derivative by hand because it's so easy, and I don't want to have to do the math 8 and then type in the function and then do x equals x and then put into y2 and all that stuff. Your calculator gets bogged down doing that. So these derivatives are really easy to do by hand. So the first derivative of f is going to be f prime of x is going to be equal to 3e to the 2x times 2, because you got to multiply by the chain. So you get 6e to 2x. So there's your derivative of f. The derivative of g would be just 18x squared. So all I have to do is plug these both into y equals. I'll do that with you. Okay, so I'm going to go to y equals. I'm going to type in, what was it, 6e to the what?
2x.
Second ln for e to the 2x, and then I'm going to go 18x squared. And then I'm going to graph it. I'll probably hit zoom 6 because I don't know who've had the calculator before me, and I'm just seeing where they're equal. Now, here's what's interesting is a lot of people would say, okay, are they going to cross again? They could, but I know they're not because e to the x is the most powerful function in math. And even though right now, eventually those two things are going to grow apart because e to the x is the most powerful function in math. So it's going to increase faster than x squared. Squaring is not faster than going e to the x power. So I know that the only place they cross is right here. So how do I do that?
Second trace.
Second trace.
Value.
Nope.
Intersect.
Number 5, intersect. You have to use option 5. And this is where you have to do a first curve, second curve guess. Mine's going to say it a little different. You go to where you think they cross. Mine, you have to go to the left of it. But you need to go, don't follow mine. Don't look at mine. It says first curve. Put your cursor where you think they cross using the left and right arrow buttons and hit enter. Then put your cursor on the second curve guess when it says second curve. Put where you think it crosses and hit enter. And then it's going to ask for a guess. And then it should tell you the intersection point is negative 0.39065, and then y is 2.74686. Everybody get it? So it's negative, what was it, negative 3 point what?
9.
There it is, C. You didn't get it?
Oh, no, never mind.
Okay. You got to be able to use the calculator pretty well. Next one. This one, I think this is a related rate problem. The radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. Yep, there's a dead giveaway. Related rates are always done with respect to time. So they're talking about the rate of something. And here's another thing you're going to know, because it could be a particle motion problem, or like a particle motion problem where you're talking about velocity and speed and stuff like that, because that's also done with respect to time. But here's how you know for sure it's a related rate. In terms of they talk about another variable. Related rates are always about relating multiple variables in a rate problem. It's multiplying like a volume to a radius and a height, or here a radius to a circumference. So when you're relating multiple variables, you know it's a related rate. So let's read it again. The radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. So that's dr/dt. This is why it's good to go through this, because we have to review this stuff. Decreasing, negative or positive? Yep, decreasing at a constant rate. So it's negative 0.1 centimeters per second. In terms of the circumference, what is the rate of change of the area of the circle? In square centimeters per second. Okay, what is the rate of change of the area of the circle in square centimeters per second? So I want to know in terms of the circumference. So I want to put my answers. Notice your answer is going to be in terms of the circumference. I want to know what is the rate of change of the area of the circle. So I want to know dAdt. So dAdt in square centimeters per second. Well, obviously area is square centimeters. So I want to put area in terms of circumference. But the only area formula I know for a circle is what? What is the area formula for a circle? Pi r squared. Problem is that area formula is in terms of r, which we have dr/dt. That's great, we have dr/dt. But the problem is I don't want dr/dt. I want to have it in terms of circumference. So here's what you have to do. You have to take your circumference formula. There's one of two ways you can do this. You can do it right now, and most people do. They just change their formula. Or what they'll do is they'll change their formula before they take the derivative, or they'll change their formula after they take the derivative. But at some point, I have to replace radius with circumference. So I'm going to wait. Because I think most of you would just take the derivative right now, and you would get dAdt is equal to what? 2 pi r times dr/dt. And this is actually pretty easy, because they want to, remember, we want to know what dAdt is. Well, we got dAdt. Well, they want it in terms of the circumference. Well, what's the formula for circumference? You do have to have this memorized. 2 pi r. Oh my gosh, look there. 2 pi r. 2 pi r. What can I replace 2 pi r with? C. So dAdt is equal to C times dr/dt, which we know, which is negative 0.1. So there's my answer. C times negative 0.1, the answer is B. That one's pretty straightforward. You'll have to practice a couple of those. We'll do a lot more related rates as we do practice exams. All right, the graphs of the derivatives of f, g, and h are shown above. We are looking at not the original function, but the what? The derivative, right? We're looking at the derivative. So the graphs of the derivatives of f, g, and h are shown above. Which of the following functions, f, g, or h, have a relative max on the open interval? Well, remember, when you're looking at the graph of a derivative, you're really looking at a sign analysis. Okay, so we're looking at a sign analysis. So here's what I know. For f prime, I know it's below the x-axis, which means the original function's decreasing because the derivative's negative. I know it's above the x-axis, which means the original function's increasing. And I know it's below the x-axis. Well, I need to be able to go to get a relative max, we need to go from increasing to what?
Decreasing.
Is this going from increasing to decreasing? Yeah, it goes from positive to negative. So yes, that's going to have a relative max. Let's look at G. Is G going to have a relative max? It goes from below to above. That would make that a relative what? Min. So that's out. So anything with G, you can cross out now. So it's probably F only. I probably don't even have to go any further, but I'm going to double check. H is always what? Since H prime is always positive, what is H? Always increasing. It's a strictly increasing function. So H is out. So the answer is F only. Okay. The first derivative of function F is given by, all right, this one probably going to need a calculator for, because they give you an equation. That's another reason why you know to use the calculator. It's either decimal answers or they give you an equation. On the calculator part of the exam, if they give you an equation, I usually instruct students, just go ahead and plug it in right away. Now, I know there was the one problem where we had two functions and it was easier to take the derivative by hand. But this, you only have one equation. I think go ahead and plug that one into y equals. So the first derivative of function f is given by f prime is equal to cosine squared x over x minus 1/5. How many critical values does f have on the open interval from 0 to 10? So all I got to do to look for critical values is where the first derivative equals what?
0.
Or undefined. Now, your calculator is going to be deceiving with this. Now, let's go ahead and rule out one thing. Is the first derivative ever going to be undefined?
No.
What's the only three problems in math? Zeros in the denominator. Are there any zeros in the denominator? Yes, so automatically we know x equals 0 is going to be a critical value. Okay, x equals 0 is going to be a critical value. So that's going to be a 0 in the denominator. So there's going to be at least one critical value. Square roots is the other place. You can't take square root of a negative, and logs, and we don't have square roots or logs. So the only thing we're worried about here is a 0 in the denominator, and there is a place, 0. Okay, so there's one critical value for sure. But I'm going to use the calculator to look at this. So it's cosine squared. So here's how you type it in, because I know some of you are probably like, how do I type this in? I'd use alpha x, parentheses cosine x, close it, and then you got to double close to square it. See, this is part of the problem. You've got to be able to type things in correctly. Okay, this is where most people have a hard time. So it's cosine squared. Because remember, cosine squared x is the same thing as cosine x, the whole thing squared. Was it minus 1/5 or plus 1/5?
Minus.
I don't need to do math alpha x for 1/5. I can just type in 1 divided by 5. Press zoom 6 again, just in case I change the window. All right. Now, this is where it gets a little weird. Let's make sure we go back. They said the open interval from 0 to 10. So what do I want to do first on my calculator, since it's the open interval from 0 to 10? Change your window. Now, do you notice open interval from 0 to 10, they're not including 0?
So
Ooh, that's sly.
That is one of ours.
0 doesn't count now.
Oh, wow. Wait. Because it would have to be a bracket.
It'd have to be bracket 0 to 10, and it's an open interval. So 0 is not a critical value. So I'm starting over with 0. That's why the
Tricky.
It is.
So 10 can't be either.
All right, 10 can't be either. 0 or 10 can't be. So I'm going to just set my window, go window, and just set your window from 0 to 10. So that I'm only looking from 0 to 10. And that way 0 is at the left end of your screen and 10 is at the right end of your screen. All right, now, here's the next part. It is really hard to tell where it crosses the x-axis. So that's what we're looking for, where the first derivative equals 0. So I'm looking for where this graph crosses the x-axis. So what I would do is I'd shrink my y window. I'd shrink it down. We don't need to be from negative 10 to 10. I would maybe go from what?
From -1 to 1.
Yeah, just try negative 1 to 1. I think that's going to be enough. If it's not, we'll change it again. Oh, yeah, that's enough. Now, can you see how many times it crosses the x-axis from 0 to 10?
Once.
Okay, I got to change my y-min 0 to 10. Oh, I see. It crosses more than once.
No way.
That's no my. Wait, is that what your guys looks like?
Is your calculator in
Mine does
radians?
not look like that.
Because your calculator's not in radians because the kids from the ACTs used these yesterday.
That's in degree.
Oh, it's got to be
I
in
have
radians.
more rings on my screen.
You got to be in radians.
It's ridiculous.
Yours will be in radians before you take the exam, so this wouldn't be an issue. So how many are there?
Okay.
3.
Looks like there's 1 here, 2 here, and 3, and that one doesn't cross. And if you're unsure, you could shrink it down even further from instead of -1 to 1, you could shrink it down to -1/2 to 1/2. But I can clearly see it doesn't cross. But if you're ever uncertain, you can shrink it down more. So 3 times the answer is B. That was a good one. 81. This looks like this is going to be a non-calculator problem because I don't have any. Maybe not. Maybe you need the calculator a little bit. But you guys know common graphs, so I don't think you're going to need to. Let f be the function given by f of x equals the absolute value of x. We know that's a what?
Flying V.
That's a flying V. It's a bird. Not a bird, a flying V. Which of the following statements of f are true? Is f continuous at 0? It's not.
Oh, continuous.
I'm saying continuous.
Mm-hmm.
It's definitely continuous. Continuous. Three parts of continuity. The limit must exist. Does the limit exist? The function must be defined. Is the function defined? Yep, f is 0, 0, and the limit value has to equal the function value. The limit exists, the function's defined, and the limit value equals the function value. It's not differentiable, so that is out. Can't be diff because of the corner. Does it have an absolute min?
Yeah.
So 1 and 3. D. No calculator was necessary for that problem. All right, f is a continuous function where f prime is equal to little f for all real numbers. Then the definite integral from 1 to 3 of f of 2x dx is equal to. All right, we kind of talked about this yesterday. We're actually going to learn FTC, but this requires chain rule for integrals. So let's go back. If you took, because the derivative of big F is what?
Little f.
But there's a 2x in there. Do you see that chain rule would have been used? So big F had to be f of 2x. But if you took the derivative of f of 2x, there would be, if you took the derivative of that, it'd be f prime of 2x times a what?
2.
But is there any 2 outside of it? Is there any 2 anywhere?
Oh, do you-
Is there a 2 out here anywhere? Do you see a 2 anywhere?
No.
That's what you have to do.
Divide by 2.
You got to compensate for the 2 that's not there by multiplying it by half. So your antiderivative of this would be big F of 2x times a half. And then evaluated from 1 to 3. And we're going to learn FTC today formally instead of just me kind of saying, hey, did you come to the morning session? So now the 1/2 I can leave all the way out front because that's constant multiple. So I'm going to have 1/2 times, it'd be f of 2 times 3 minus, remember it's in position minus start position, f of 2 times 1. Oh, you guys glad you're here, man. This was a good one.
Ooh,
So it'd be 1/2 times f of 6.
the end is 3 and the start is 1, right?
Yep, so in position first, plug in the 3 first.
Oh.
Plug in the 3 first. And then plug in the 1. Minus f, big F of 2. Here it is, so we just need a 1/2. They got the 1/2 distributed, so the answer is E. Mm-hmm. So the answer is E, 1/2 of f of 6 minus 1/2 of f of 2. All right, limit. Let's see. Maybe we can use L'Hopital's rule. Maybe we can just do direct substitution. Or maybe it's really easy to do with factor cancel. Okay, let's plug in A. If I plug in A, I get A squared minus A. That gives me 0. If I plug in A on bottom, I get A the 4th minus A the 4th. That gives me 0. 0 over 0. You could lose L'Hopital's rule if you wanted to. L'Hopital's rule is take the derivative of the top, take the derivative of the bottom, and then try direct substitution. Or if you wanted to, you could factor cancel and do this. Which way do you want to do it? I don't really care.
Let's do L'Hopital.
How about I do it both ways, and then you can decide which way you like better. If you factor cancel, the limit as x approaches a, the top I actually would leave alone because I recognize the bottom is going to factor into x squared minus a squared times x squared plus a squared because it's a difference of two squares, and then the x squared minus a squared cancel. Do you see that? Now I can plug in a. If I plug in a, I'll get a squared plus a squared, which is 2a squared. So the answer is B. Now let me do it with L'Hopital's rule.
Oh, I like that one better.
You do? I like L'Hopital's rule really well here. Here's why. Because the derivative of the top is super easy. Watch this. The derivative of the top is just 2x. The derivative of the bottom is 4x cubed. Because a is constant, derivative of constant 0. So the
Well,
derivative,
it's minus 2, it'd be 2a, wouldn't it be?
watch. Do you get that the derivative is 2x?
Yep.
Because derivative of a squared is 0. Do you get the derivative of 4x to the fourth is 4x cubed? Derivative of the constant 0. And then I can cancel out an x. That gives me a squared. And now
A is 0.
plug in my a. What? A's not 0. The derivative of a squared is 0. I'm doing L'Hopital's rule.
Is that like given by?
Derivative of a constant is 0.
But it's not a constant, is it?
Yes, a is a constant. A is not a variable. A is a constant.
Is that just saying a equals 0? Or
No, it's just saying a cannot be 0. Because you can't have 0 in the denominator. Because if a does equal 0, you get a whole.
Okay, but it's a variable squared. How, it just is.
But you got to treat a as a constant. The only variable in my equation is x. This is the variable of the equation. A is a what? A constant. So the derivative of a constant is 0. So then you cancel out the x's, and then you plug in a, and I get 2 over 4a squared, which does simplify to 1 over 2a squared. So you get the same answer either way, whatever your preference is. All right, if you came the other morning, you saw me solve this. And I said memorize it. CE to the KT. So you know I'm going to show you again. PERT, yes. I'm going to show you again how this works. If you came the other morning, you saw me solve this. First of all is you separate the variables. So you got a y and a t. K is your constant. It even says this time K is constant to make sure you know K is constant. Now here's what, it would save you time if you already knew that y is going to equal CE to the KT. Like that's what we're going to get here in a second. If you have this memorized, you won't have to do this work. But you multiply both sides by dt, you get dy is equal to ky dt. Then you divide by y and you get 1 over y dy is equal to k dt. You might as well leave the k with the dt. Then you take the integral of both sides. What's the integral of 1 over y? We did this the other day. What's the integral of 1 over y? You got it memorized?
Y to the negative.
No, you can't do y to the negative 1. Simple power rule does not work with y to the negative 1. It's natural log, absolute value of y equals the derivative of k dt is just going to be what?
Okay. I memorized this very well.
Nope, we did not.
I don't remember this
Yeah,
part.
doesn't the integral cancel the dt?
Yep, but what's the integral of just a constant?
0.
Oh.
Nope, what'd you take the derivative of to just get a constant?
K,
KT. Yep, there you go. There you go. KT or KX.
KX.
All right, now, yeah, we're doing an integral, not a derivative. Now you got to go full what? Circle. So you get absolute value of y is equal to e to the KT. Remember that? There it is.
I have like the ln.
Well, that gets rid of the ln when you go full circle. Oh, wait, we have a plus c too. I forgot the plus c. Ooh, golly, that was scary. So it's e to the KT plus c, actually. Now, remember what we did here? We did 8th grade math. We split the power. So remember how we split the power? We went e to the KT times e to the c. And then what did we do with e to the c? We just called it what? What did we just call this? C. Because e is a constant, c is a constant, so we'll just call it a new constant. So y, and we drop the absolute value because that gives us a plus or minus. So we got y equals plus or minus C e to the KT. So it just says that it can be positive or negative. Now, population grows according to the equation where K is, so if you had this memorized, you wouldn't have to do any of this work. You'd just go right to Y equals C to the KT. If the population doubles every 10 years, what's the value of K? All right, so do we know what the beginning population is? So make up any population you want. What's the easiest number to use on planet Earth? 1. Start with a population of 1. Okay, you can't start with a population of 0 because then your population can't grow. So you gotta have to at least have one person in the beginning. Okay, so we're gonna have Y equals 1 person. Now, if the population doubles every what? So in other words, in 10 years, how many people would you have?
10 to the E to the K.
We got one person in the beginning. You got one person in the beginning. You're going to double every 10 years. What does double mean?
0 to 20.
Nope. You got one person. In 10 years, you'll have what? 2 people.
We made that really hard.
Yes.
2 equals.
So then you just solve for K. So you got 2 equals E to the 10K. Does anybody remember how to solve for this? Take the what of both sides? Natural log. So you have natural log of 2 is equal to natural log of E to the 10K. What happens to the natural log of E? Cancels. So you get natural log of 2 is equal to 10K. Divide both sides by 10. K is equal to the natural log of 2 divided by 10. Type that in the calculator and you'll get your decimal. Now, some people are like, that's a lot of work. You shouldn't have to do any of this work over here. Natural log of 2 divided by 10, what is that? Well, this is the growth constant. This is how it's growing.
0.069.
Yep, so A.
But so then you're just supposed to know to use 1 as the start.
You could say C. You could do C and just go C e to the 10K. But then when it doubles, you're going to have to put 2C over here. I just pick a number. I think it's easier to pick a number. If you don't pick a number, you have to use a generic C.
Would it work with any number?
It would work with any number. If you pick 5, then it'd be 10. And if you pick 6, it'd be 12 in 10 years. You can pick any number you want.
Oh, because they're just the natural log.
Yeah.
Number would change.
Well, because when you divide, if you set it equal to 10 instead of 2, so if you started with 5 people, 5. So let's start with 5 people. 5 e to the KT. So K times 10. So in 10 years, it's going to double. So then it equals 10. Well, then you divide by 5 first. So you're going to get 2 anyway. You still get this. 10K. It doesn't matter. You can start with 6 and go to 12, but when you divide by 6, you'll get 2. You can start with 10 and go to 20, and when you divide by 10, you'll get 2. You're always going to get it equal to 2. In fact, a lot of people will just skip it. I do. When I say it doubles, I just know to set it equal to 2. If it tripled, set it equal to 3. Because I always just start out with 1. Okay? This is a good one. F is continuous. You guys should be able to do this one. F is continuous on the closed interval from 2 to 8, no leaky area, and has values given in the table above. Use subintervals 2 to 5, 5 to 7, 7 to 8 with a trapezoid approximation. So we're going to estimate the area using trapezoids. And guess what? They've already subdivided it for you. They said go from 2 to 5. There's your first trap. 5 to 7 is your next trap. And 7 to 8 is your third trap. Now, some people have a hard time seeing this, so they're like, Mr. Morris, can I draw it so I can see the traps? If you feel like you need to, I guess. Okay, you got 2, you got 5, you got 7, and you got 8. And then 2 is at like 10, 5 is at like 30, 7's at 40, and 8's back at 20. So this is what it looks like. The first trap would be like this. And the curve, I don't know, the curve's like this, but second trap would be here and third trap would be here. So what's the width of the trap actually represent?
B minus A.
The B minus A, yes, but it's the height of the trap. So you got to go for these when you do it. Okay, so first of all, I'd put the 1/2 all the way out front. Do you agree? So 1/2 is common because the formula is 1/2 the base times the sum of the heights. No, sorry. I got that backwards. It's 1/2 the height times the sum of the what? Bases. The bases are the ones that are parallel. Can you see the ones that are parallel? Those are the parallel sides. Those are the bases. All right, so we got 1/2. The 1/2 is common no matter what trap you're doing, so I can put the 1/2 all the way out front. The first height would be 3. Sum of the bases would be 10 plus 30. Plus, what's the next height?
2.
First height was 3. Next height is 2. Well, we already got the 1/2 out front, so I don't need to do that. 2 times 30 plus 40. Plus, what's the next height? 1, and it'd be 40 plus 20. And you have a calculator, so don't do too much work. Just type it in the calculator and get your answer. I'll race you. Let's see, that'll be 40, 120, plus 70, 140, plus 60. That's 200. That's 200. That's 320. Half of that is 160.
Yeah.
That was a little faster.
No need to flex.
Mm-hmm. I just did.
So let's do the
Masters in math.
All right, this one you don't know how to do, and I'm going to teach you later.
Why are we all bringing in drinks?
Yeah, what are these drinks?
For cross concessions for the track meet tomorrow. Yeah.
Yeah.
Mm-hmm.
I know where it stays. That's my favorite thing to say to people. Like, what did you say? I mean, like when you keep trying to say it.
Oh.
All right. If I'm going to show you,
You only have negative minutes.
how much more do I got?
A lot.
Not much.
Bit.
Okay. I would love to show this, but basically what's going to happen in a week, we're going to take this thing, drop the y-axis flat. We're going to imagine this thing in 3 dimensions. And you're going to imagine the base of the solid as the region in the first quadrant. Listen, watch this. The base of the solid, so you've got a solid, a 3-dimensional object, is the region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8. So if cross-sections of the solid are perpendicular to the x-axis are semicircles, so what you have to imagine here, this is wild.
It's like this, and then it forms like a 90 degrees at the top.
Oh, is this the lamp shade thing?
No, yeah, kind of. It is like that. So what you get is you get like this. You get, there's 4. Here's 8 over here. So I'm dropping it at flat. And what you get is you get, they're perpendicular to the x-axis, and you get a semicircle. This one's going to look like a bugle. Have you ever ate bugles?
Oh, so okay.
It's like a cornucopia. You ever seen those at Thanksgiving?
Yeah.
I'm going to see.
Now,
I'm going to.
no, this is super easy. Once you learn how to do it, the formula makes it easy. You don't even have to be able to draw it to do it. Like you just basically say, okay, that right there is the diameter of the circle. I'm just seeing it in 2 dimensions. It's from up top. And so what you do is you split the radius, going the area under the curve, and then you just integrate the area of the semicircle is all you do. So we'll get to that later. It's not hard at all. Most people are like, man, I'm going to do that one for sure because it's easy to do once you learn the formula. All right, 87. Which of the following is an equation of the line tangent to the graph at this? Okay, so what I want to know is I want to know which of the following, and look at this, you got some decimals, so you know you're going to need the calculator here. Which of the following is an equation of the line tangent to the graph? So I want to see when this graph has a tangent line that has a slope of what?
1.
So I need to find the derivative and set it equal to what? So I find the derivative. I do that by hand. Let's don't use the calculator for that. What's the derivative of that?
4x cubed plus 4.
And all I got to do is set that equal to what?
1.
Now, it's up to you how you want to solve this. You can either type both of those into y equals and see where they cross, or some people like to set it equal to 0 and then use the 0 feature. They like to set it equal to 0 and type that into y equals and see where it crosses the x-axis. It's up to you. You can either plug this into y1 and that into y2 and see where they intersect, Or you can set it equal to 0 and just plug one equation to y equals and see where it crosses the x-axis. Tell me your preference.
Ooh.
They're going to give you the same answer either way. Let's just do both. How about let's just do both ways. So what I'm going to do is I'm going to go back to y equals. I'm going to type in 4x cubed plus 4x. 4x cubed, was it plus what?
4x.
And I want to see where that equals 1. Then I'm going to go to y3 and I'm going to type in the derivative when it was set equal to 0, not when it was set equal to 1. So it was 4x cubed plus 4x minus 1. 4x cubed plus 4x. Now, you don't have to do both ways on the AP exam, but I'm going to show you both ways work. So the first way is to see where the red and green, the blue and red intersect. So I'm going to zoom 6 it. Everybody zoom 6 it. Does everybody see that where the red and blue intersect is the same place as where the green is going to cross the x-axis?
Yeah.
So either way you do it, it's going to give you the answer. So either see where the green crosses the x-axis by using second trace 0, or see where the red and blue cross each other by using second trace intersect. You're either going to use 0 or intersect.
Hey, I think that Chris marks.
Oh, that's all you want from me. Okay, so I'm going to do second trace. I'm going to do the green one. I'm going to do the 0. So you have to do a left bound on the green one. Where am I at?
I like the intersect, honestly.
You do? Okay, fine, whatever. Left bound a little bit to the left, which is below, a little bit to the right, which is above. I got 0.23673. Is that what you got?
Yeah.
So it crosses, where'd it cross at?
0.23673.
0.236,
73.
and what was the y value?
1.
So there's my point. Now I just need point slope form to find the equation. So you go y minus 1 equals 0.23673 times x minus, no, sorry, that's not my slope. What was my slope? What was my slope? What was my slope of my tangent line? 1, sorry. 1 times x minus 0.23673. Okay, so I distribute the ones. I'm going to get y minus 1 equals x minus 0.23673. I'll add the 1 to both sides. So I'm going to get, what is negative 0.23673 plus 1?
Positive 0.236.
No, there's no way it's positive. I think it's 0.7.
Oh, yeah.
0.76327.
There you go. The answer's C. Number 88. Let big F of x be the antiderivative of this. Oh, okay. Big F of x is the antiderivative of this. Oh my gosh, you're going to love this. So big F is the antiderivative of this. So this is little f. Okay? And f of 1 equals 0. Find f of 9. So here's what you want to do, is you want to figure out where f of 9 is at. To figure out f of 9, ready? You're going to need this a lot. If you wanted to figure out f of 9, here's what you could do. You know f of 1 is equal to 0. So what you could do is you could figure out how much is displaced from 1 to 9 and add it to f of 1. So if you want to figure out f of 9, you know where f of 1 is at, right? If you add the displacement from 1 to 9, how much it increases or how much it decreases, which is area under the curve. If you add how much area is under the curve, whether it's positive or negative, you'll figure out where f of 9 is at because you know where f of 1 is. There's no plus c. Remember when I told you have a point? The plus c gets taken care of. Remember, we were finding the plus c yesterday. But if I give you a start value, do you have to worry about a plus c? No, because it nails down which function it is. So you know where you're starting. Your graph, here's the deal. F of 1 is equal to 0 on the original function. So whatever the displacement is from 1 to 9, the area under the curve will tell you how much it either goes up or how much it goes what? Or how much it went up and. And then you can figure out where it's going to be at f of 9. So all you got to do is figure out the displacement from 1 to 9 of this function ln of x quantity cubed over x dx. Because remember, big F is the antiderivative of this guy. So all I got to do is figure out f of 1 plus that. What was f of 1? What was f of 1?
0.
So I'm just going to go 0 plus the definite integral from 1 to 9 of ln x to the third over x dx. You have a calculator, so what can you use? Math 9. You can go 0 plus that. So you're going to math 9. Math 9, definite integral from 1 to 9 of ln x in parentheses to the third power divided by x dx. And tell me what you get. I need something to eat. My stomach's killing me.
This is so easy.
That is. What do you get?
2.413.
You did it wrong.
Oh, cubed.
Are you correcting him?
Which version do you have?
Just says
No
assignment.
negative.
Oh, I don't.
Is this it?
5.8.
Just says assignment infinite.
Yeah, I didn't. Okay, I
You have this one. Check it. What'd you get?
5.8269.
Yep, so C.
Um.
You got to put the ln x. When you put it in parentheses, you probably alpha x. It's the best way. On your calculator, you're going to have definite integral from 1 to 9, and you're probably going to go parentheses, ln parentheses x, close that parentheses, then to the third divided by x dx. That's the only way you can do it on the calculator. Unless you were to go put the function into y equals, and then use var's function y1 on the home screen.
I went
Not,
9.
wait, not.
I went 9 to 1.
5.826.
Is mine right?
No, I went 9 to 1. That's my bad.
It's 1 to 9.
Wait.
Now I got it. Plus.
What'd you get?
I still got the same. I was looking at the same answer. I just
It's
took
5
away
point.
negative.
It's 5.826.
Yeah.
Well, the reason you got negative, you go 9 to 1. It's going to be flipped around. All right. Last couple problems. If g is a differentiable function such that g of x is less than 0 for all real numbers x, so they're telling g of x is less than 0, which as long as true. All right. First of all, if you have f prime, and g is a differentiable function, which means it has no corners, cusps, for vertical tangencies, right? And it's continuous, right? And they're saying g of x is less than 0 for all numbers. So if g of x is less than 0 for all real numbers, is there anywhere where g of x would equal 0? G of x is always what?
Always less.
It's always less than 0. It's always negative. G is always negative. That's what that means. Now, you want to figure out relative extrema. For f, it says which of the following is true. Okay? You want to figure out relative extrema. So what you're going to do is you're going to find the critical values for the first derivative. Well, critical values for the first derivative is where it equals 0 or undefined. You already said g can't equal 0, correct? So the only place it can equal 0 is where x squared minus 4 equals 0. What's that going to give you?
Plus or minus 2.
Plus or minus 2. So my sign analysis is going to be from negative infinity to negative 2, from negative 2 to 2, and from 2 to what? All right, now let's do a test value. And they already told you g of x is always going to be what?
Negative.
What'd they say about g of x? It's always what?
Negative.
So we know that's automatically going to start with a negative when I do my sign analysis. So when I test 0, that's going to make this negative, and that's going to make this negative. A negative times a negative is a what?
Positive.
Now, if you're unsure if they're not alternating, let's go through. Negative 3. Negative 3 would make this what?
Positive.
And this is always what? So that'll be negative. So it should alternate. 3 makes this positive again, right? And that's always what? So yes, it does alternate. You wanted to know, all right, it says what is true. We've got a relative min, and then we've got a max, because it changes from, so we got a min and we got a max. We got a min at negative 2 and a max at 2. So the answer is B, relative min at negative 2 and relative max at 2. There you go. Okay, is this the last 3 problems? Okay, if the base of a triangle, is another related rate problem. Here we go. If the base of a triangle is increasing at a rate of 3 inches per minute while its height is decreasing, so we've got dB dt is increasing at 3 inches per minute. We've got height, dH dt, is decreasing at negative 3 inches per minute. Which of the following must be true about the area of a triangle? What's the area formula for a triangle?
1/2 base.
There you go. Does that relate base and height? That's why it's called a related rate. That relates base and height to the area. All right, can we do the derivative of this implicitly with respect to time? Okay, because they want us to find dA dt. We want to know something about dA dt. It says what must be true about the area of the triangle. So how do I do the derivative of this with respect to time?
DADT.
1/2 times, what are you going to need for B and H? Product rule. So it'd be dB dt times H plus dH dt times B. All right? And all we're going to be able to say probably is what we can say is true about area. So we know 1/2, this would be dB dt is 3H plus, or minus, because it'll be minus now, because dH dt is negative 3B. So let's see. 3H minus 3B. A is always increasing, A is always decreasing, A is only decreasing when B is less than H. All right, well, yeah, this kind of makes sense. If I factor the 3 out, so look at this, H and B. Okay, so I factored a 3 out. Is that okay, everybody? We have the derivative, so let's set the derivative equal to 0 to figure out increasing and decreasing. So if I set H minus B equal to 0, I get H equal to B, right? So when H is equal to B is when, so that's where the tipping point is. So if H is bigger, the area will be what? Increasing. If H is smaller, the area will be what? So I got to figure out that. So it's definitely not always increasing. It's definitely not always decreasing. So A is decreasing when B is less than H. No, because it's H minus B. A is decreasing when B is greater than H. Is that true? If B is bigger than H, is that going to make it negative? Yes, the answer is D. And A is definitely not going to remain constant because we're subtracting H and B, and there's going to be a point where, you know, when H is bigger than B, it's positive. When H is smaller than B, it's negative. All right, last problem, or last 2 problems. Let f be a differentiable function on the open interval from 1 to 10. Let f of 2 equals -5, and f of 5 equals 5, and f of 9 equals -5. All right, let f be a differentiable function. This means IVT, MVT, and EVT apply. All right, this gives you f of 2 is equal to -5, f of 5 is equal to 5, and f of 9 is equal to -5. Wow. All right, looks like this is going to be a problem where they're saying, okay, you're at -5. So at 2, you're at -5. At 5, you're all of a sudden at what? And then at 9, you're back to where?
-5.
And it's differentiable, and I don't care what it does. I mean, it could do anything. But I can't skip values, right? Because it's differentiable, and differentiable automatically means what? Continuous. So does it have at least 2 zeros? Yeah, because if you start above at -5, go above 0, and then go below 0 again, you're going to have to cross the x-axis how many times? So it has to have at least 2 zeros. The graph has to have at least 1 horizontal tangent. Well, yeah, because by EVT, you're guaranteed an absolute what? Max or and they can occur at endpoints or what? Critical values. Well, if they go up and then back down, you have to have at least 1 horizontal tangent. Agreed? So this one's true. This one's true. All right. For some C from 2 to 5, does f of C have to equal 3? As long as I can show the slope of the secant is equal to 3, I have to show where there's an AROC equal to 3. So I can only take the points I'm given. So I need to show that if I take the slope between either these 2 points or the two endpoints or these 2 points. You're just gonna have to sit there and figure out the slope. Let's take these two first. So you gotta have a 5 minus a negative 5 over, so 5 minus a negative 5 over 5 minus 2. That'll give me 10 over 3. Does that give me a slope of 3? So no A-rock there. Now let's take this one with this one. So I have negative 5 minus a negative 5 over 2 minus 9. That's going to give me 0 over negative 7. That's not going to work. One more possibility. Take the middle, take the second and the third one. 5 minus a negative 5 over 5 minus 9. That gives me 10 over negative 4. So I got 10 over 3. I got 0 and 10 over negative 4. Did I ever get 3 for an A-rock? There's no A-rocks equal to 3, so mean value theorem says that the A-rock has to equal the I-rock. But if you don't have an A-rock of 3, you can't say the I-rock's going to be 3. So we're only talking about 1 and 2 only. So the answer C. Last problem, the area from 0 to pi over 2, the area under the curve of cosine from k to pi over 2 is 0.1. So what is k? So the area from k to pi over 2, and they're saying they're positive, so k has to be some positive number. So you could, well, there's no negative number, so you don't have to worry about that. So we're saying the area from k to pi over 2 of cosine x dx is equal to 0.1. All right, this is actually easy. You don't even need a calculator for this. What's the integral of cosine?
The integral?
Mm-hmm. Sine. Evaluated from k to pi over 2.
Isn't it negative?
No, derivative of sine is cosine. Huh? Oh, yeah. 0.1. Now, if it would have been integral of sine, then it would have been a negative cosine. Okay. Now, we know the area is equal to 0.1, so I can do in position sine of pi over 2 minus sine of k is equal to 0.1. So we know we already know what the displacement equals. It has to equal 0.1. What's sine of pi over 2? Up here, it's the y. It's 1 minus sine of k is equal to 0.1. I'll subtract 1 from both sides. So I give me negative sine of k is equal to negative 0.9, right? Divide by negative, and I get sine of k is equal to 0.9. You need your calculator for this. You got it.
It's 0.1 or 1.1, negative 1.1, isn't it?
No, because it equal
0.1 minus 1 would be
negative 0.9.
negative 1.1, right?
No,
It's positive
It's
0.1.
positive.
Now, you got to use inverse sine. Calculators in radians, what's inverse sine of 0.9? Because the only way to solve for k is you got to do inverse sine. So you got to do inverse sine of 0.9. What is it?
1.99. 1.119.
How do you do inverse on the second?
Second sine. D. The answer's D. There you go.